Hello everyone, welcome to my talk. Today I am going to present FlinkCDC, Streamlining Your Data Analytics Pipelines. Does anyone know about Apache Flink? Raise your hand. Okay, good. FlinkCDC? Okay, good. So let's get started. Let me introduce myself. I am Muhammet. My background is on database and distributed systems. And recently, almost 2 years now, joined Fairworker, and I also start learning about the streaming systems. My team at Fairworker maintains many different Flink engines for our different products. For example, managed cloud or bring your own cloud. And we also do many optimizations, also try out new things, such as native runtime for Apache Flink. And on my spare time, I enjoy playing board games and doing sports. So this is agenda for today. I will start by introducing change data capture and what tools are available for it and what's its use cases. Then I will talk about the FlinkCDC and introduce its APIs and talk about the internals of the FlinkCDC. Then I will do a short demo and conclude the presentation and answer your questions. So let me talk about the change data capture. CDC actually is a technique for tracking or capturing changes applied to the database over time. So it's a pattern, not a tool. It's a powerful pattern in many data-related systems, and recently have seen adoption in many organizations. The main reason for this is it enables to integrate your transactional database, such as Postgres or MySQL, into your data analytical infrastructure for your business use cases with a low latency. And with the CDC, responds to the database changes, such as insert, update, or delete events, and send these changes to the other systems in real time for integration or further processing. There are many ways to do to implement the CDC solution. For example, a query or trigger based, but most common or powerful approach is to use a log-based CDC. In this solution, the changes are obtained from the transactional logs, and most of the database have them. For example, in MySQL, it's called the bin log or binary log. In Postgres, it's a write ahead log. And for example, in MongoDB, it's called operational log. There are many benefits to the log-based CDC, but main advantages are it's very resource efficient, doesn't miss any changes, including deletes, and it doesn't also affect your data model. So to use a log-based CDC, you don't have to change or design or do architectural changes to your data model. Such a need have been in industry for many years. There is another nice article from Martin Kleppmann named Turning the Database Inside Out with Apache Samza. The article has many interesting ideas, but I'm not sure if you can see it. I quote, the one point there is, a more fruitful approach is to take the streams of facts, like these events applied to the database, as they come in and functionally process them in real time. And on the very next paragraph, he mentions that it's a sneaky attempt to take the database architecture, as we know, transactional database architecture, and turn it inside out. And with the FlinkCDC, we can do this nowadays. So what are some of the CDC tools? There have been many throughout the years. Most of them are built in-house in many companies, or they are specific to certain database. For example, Postgres has many open source tools which you can use for the CDC. And there are also some other open source tools for all database, or most of them, like unified approach, such as Canal and Maxwell. There is a nice talk from Marta Payas about the CDC tools from the last year's current conference. You can check it out for more information. But most well-known tool is the Debezium. The Debezium provides unified record format to model the changes. And for the updates, it also describes the state of the update before and after the update. It also contains metadata about the database or the table itself. And one important point is the Debezium also provides position or offset of the change inside the transactional log, which is inside the transactional log. So an example on the right, you can see a JSON schema of the Debezium format. So it's for the update in the payload. There is a state for the before the update and also the after the update, and many metadata like time of the update, offset in the transaction log, and the operation or the source. And Debezium has a really rich community and ecosystem with many connectors for different databases. And FlinkCDC also uses it for the MySQL and Postgres integrations. Yeah. So what are common use cases for using CDC? You can do the audit logging. So every change which is applied to your transactional database can be considered a form of audit log, but maybe it's not rich enough, so you can also use FlinkCDC to combine it with other metadata sources and enrich the audit logs. You can do real-time data analytics. Again, do the ETL in real time when the change is applied to the database. And I will have some demo about this later on. And you can also use it for the data exchange or migrating your monolith to the microservice architecture to send every change or every update into the message queues, such as Kafka to propagate to other systems. And finally, you can use CDC to update your search index, for example, or even invalidate some caches in your infrastructure. It's a very powerful pattern to use for real-time data-intensive applications. Okay, let's talk about the FlinkCDC. It's a distributed streaming data integration tool for batch and real-time data. As we will see in the next slides, FlinkCDC allows your data to move from the source to any target system at a speed which is required by your business. So FlinkCDC is a streaming data integration framework. It has many use cases. For example, you can use it for data synchronization, moving data from some source databases into the target systems. It can be, for example, an OLAP-based warehouse. You can also use FlinkCDC together with Apache Flink SQL as a SQL connector, and this lets you create a kind of materialized view of your source database. Additionally, you can use FlinkCDC to distribute data from one source to multiple destinations. So you can send, using the FlinkCDC, send every change to the message queue, such as Apache Kafka, and then all the other systems can use this message queue to update their data in real time. So also, for example, you can send all your events in real time, for example, ClickHouse or data lakes such as Iceberg or Pymon. So from ETL perspective, you can also use FlinkCDC to combine your source transactional data with other multiple external sources, and also using the Apache Flink SQL, enrich your resources and send it to your next systems. In the earlier versions of the FlinkCDC, it only provided the source connectors, which could be used by the Apache Flink. This helped to simplify data integration infrastructure. For example, instead of using Kafka with the Debezium cluster or connector, you could replace that system with the FlinkCDC. And for example, instead of using the Kafka and other Debezium cluster shown above, you could use FlinkCDC to read from the MySQL transaction log and directly read data from the MySQL log. And yeah, in this case, FlinkCDC already does changelog reading using the internal Debezium embedded library. But in the earlier versions of the FlinkCDC, source connectors had one drawback. They imagine you have a huge table, and if you want to use FlinkCDC, you need to first read the huge table before start reading the changelog. So for that, the FlinkCDC was taking a log on a table and then reading the snapshot of the table and then switching to the changelog reading mode. But in this, for taking a log is not very good approach because it's not very user-friendly, and even your DBA will not allow it, because until the snapshot is read, no one can write to that table. So, and then in recent versions, it's FlinkCDC 2.0. We introduced a new algorithm that's called incremental snapshot reading algorithm, basically to prevent that locking mechanism. And there was some issues also with scale-up, and with this, we also solve scale-up issues in some workloads we have seen. So in this approach, we split the database table into many chunks based on the, for example, a primary key. And these chunks are assigned to multiple readers. Each reader first uses the JDBC connection to read the chunk they were assigned. And here, of course, we use the Flink runtime underneath, and all chunk assignments and the table schema metadata information are stored in a state of the operator. So this is also helpful if there is a failure. Helps with the failover, because once the jobs are recovered, they can start where they left off. Yeah, and once the snapshot reading is done, then automatic task allocation will happen. So most of the resources which were allocated for the table reading will be decommissioned or given away to the system, and then the new task will be allocated to read from the changelog file. And this will happen also automatically once the snapshot reading is done. Yeah, with this, we perform distributed scanning of large tables, offer exactly one semantics, and of course without locking the table, and support fault tolerant using the Flink runtime. Okay, then with that algorithm, we introduced the FlinkCDC version 3.0. This here, it's not only about the source connectors, but it's a fully fledged framework. Many CDC connectors were written, and they were also migrated to the snapshot algorithm approach. And we also introduced many support for the cloud-based database, such as, for example, AuroraDB. And many other versions were added in the FlinkCDC 3.0. And then in this version, we also introduced a new API, a YAML pipeline was added, like with the new features of schema evolution. So for example, if the schema changes in the source, that will be also reflected in your whole pipeline and also the end systems. And also add, for example, support for capturing the new table additions were also added in this version. And importantly, in FlinkCDC 3.0, we donated the project from Fairwerker to the Apache Software Foundation as a component of the Apache Flink project. Yeah, with all these changes, FlinkCDC is end-to-end streaming data integration framework. Okay, let's now look into the internals of the FlinkCDC, starting with the user APIs. So we have three kinds of the APIs to use. For example, YAML API, SQL FlinkSQL API and DataStream API. And from the recent version, version 3.0, you can use the YAML API to define end-to-end pipeline from the source to the sink. And of course, you can use FlinkCDC connector. If you, for example, use a FlinkSQL API, you can use it as a source connector. And also, if you are writing DataStream, if you are using DataStream API, you can still use FlinkCDC sources. Okay, let's look at the architecture. It reflects the user interfaces. As you can see, the DataStream and the SQL API only include the FlinkCDC source. But if you are using YAML API, you will have the end-to-end data pipeline to use, so both source and sink. Here we have many support to the source and the support for the sink systems, but depending on a community or ask from the contribution from the community, we will add more sinks. For example, recently there was an Iceberg sink added, but going forward we will add many more. And for the implementation of the CDC source, as I mentioned before, we use a Debezium client for MySQL and Postgres databases, but for other databases such as MongoDB, we use a native client to read the change logs from the database. And of course, the Flink runtime powers everything. Just to mention the difference between the Flink SQL pipeline and YAML pipeline. For SQL pipeline, we have internal data structure called raw data, which matches basically the Debezium format. It collects all the events, such as list the insert, update before, update after, and delete. On the other hand, with the YAML CDC pipeline, we have internal structure for data change itself and the schema change itself. And unlike the SQL pipeline, in YAML, updates kept as a, for example, update record kept as a one record. I think the main reasoning here was to keep it, to preserve the original changelog event, like in Debezium. So Debezium, it will be, again, one payload with the update before and update after. This helps to synchronize the changelog, original changelog, into the message queues, such as Kafka. And for schema change, we detect many events added by the user, such as create table or update column. And similarly, let's also compare DataStream API and the YAML API. Same as in a SQL pipeline, the YAML pipeline uses two data structures. Here we also have, for the data change event, YAML pipeline uses schemaless approach. Each record doesn't include the schema along with the data change, which is done in a DataStream pipeline. Of course, this improves the performance by reducing the record size. Okay, an example on a YAML API. Not sure if you can see it. It's a YAML, basically, in the end. The one on the left synchronize MySQL tables to the Pymon. It's a Iceberg-like data lake format. And user only defines, okay, I have a table, but I want to synchronize all of them to the Pymon. With that, they don't have to even bother about the schema change, for example, or data type translation, and everything will be done with this, and they can start the Flink job just providing this YAML. And it will also cover, as I said, the data translation, exactly like semantics, and many more features. And all the heavy lifting is done for you. You don't have to also learn, I don't know, Java or Python to write the Flink jobs. YAML should be enough. On the other hand, there are also many, you can do some transformations, but it's not, again, powerful like writing a code. You can also do routing. Maybe some source tables should go different tables in your target system. So you can do it also with the routing and do some transformation, which is like expressions in a SQL. It's very powerful to do the integration. And in the end, you can just run, give this YAML file to the command FlinkCDC, and it will start the Flink jobs. And yeah, do the integration. Okay, I can switch to the demo now. And for the demo, I will do one example of the streaming ETL. So imagine we have an e-commerce-like application with many tables in traditional database like MySQL and Postgres. And we want to enrich it and run some queries, do the join, and then maybe also store it in a third part, in some warehouse, like, I don't know, Iceberg, Pymon, or Kafka, or Elasticsearch. Okay, can switch. Let's see. I hope the demo gods are kind to me. Mm-hmm. Oh, it's too far away. Should I increase it's visible? Should be good. Okay, so I think I need to start with I have a Docker Compose file. So like I have some database, Postgres, MySQL. Of course, to use a changelog or to be able to read the transactional log, such as write-ahead log or the binary log, you need to do something in your database. And this Debezium provided images, they do it. You need to change the configuration, okay? Allow the write-ahead log reading, for example. Okay, let's start all this. So yeah, MySQL and Postgres database should start now. And I also have scripts, if I can write, to create some tables. So I have a products table in the MySQL. I add some entries to it, and the orders table in MySQL. I also populate this one. So let's do that. Okay, similarly, I should have if I can write, tables defined in a Postgres. Yeah, I also update them with some records. Okay, so now I have 3 tables, 2 in a MySQL database and 1 is in Postgres. And I also want to start a Flink cluster. And here, of course, I added some connectors to be able to use the CDC, and most of them. Okay, let's see. It's on the Flink, SQL connector, SQL connector CDC, and the Postgres connector CDC. So I will start the Flink cluster with 2 task managers, and here. It takes a time, but Yeah, then I will switch to the SQL client to run some SQL expression. And I can show them. Okay, good. And let's go to the SQL client. Yeah, I see the big squirrel, that's good. So here, let me change color. Okay, then what I'm going to do is, so now we have databases, Postgres and MySQL, and I want to create, so I am in a SQL API at the moment. I want to create a corresponding table in the Apache Flink. I copied something wrong. So here, basically, I use MySQL CDC connector, so to be able to read the change logs. Okay, let's also do the orders. These are from the MySQL. Yeah, I also read the MySQL CDC. And then shipment information from the Postgres. Yeah, I use the Postgres CDC. Okay, let me quickly check. That we are able to read the tables. So, okay, I see some data here and also Postgres. Okay, good. Now, so I have the matching tables in my Flink application, and now I can run the queries. So let's do some joins and the projections. And when okay, I can, oh, it's not very visible. There are more columns there. Okay, I should have something. Right. So I want to reduce the width of the columns, and then let's run the join again. I think there should be some more. Okay, let me see. Yeah, destination, many columns from that. And now what I want to do is I want to add a record to my, for example, to the orders table in MySQL. So, okay, when I add that record, in real time, my query updates in my Flink application using the FlinkCDC. So we have a new record. Yeah, was reflected already the change log. And but there's no information about the shipment, which is coming from our Postgres database. Let's also add that. Sorry, I am in a different database. Yeah. Do I have the Postgres? Yeah. Should be here. And when I add the record into my Postgres table, it's already also in real time reflected on my query. So let's do, okay, insert, and we can do the update. For the last record, we update it starts to true. This is, yeah, in MySQL. And then, yeah, I'm not sure if you detected it, the status here changed. Where I am. Yeah. And let's do another update here. It's on shipments. And the shipment, the delivered was changed from false to true. And we can also do the delete. Basically, we are deleting the orders we added, the last one. Yeah, it's gone. So as you can see, the query updates its state in real time. And we can also create a sink. So now I am only seeing the results on my SQL client. But what we can do is we can also create a sink table. I have a time, right? Yeah. And this is an Elasticsearch. Okay, I have matching the sink table with which, the table will be the same columns as I expect in my query. And yeah, I basically, instead of select, I add like insert into that table the results. So this creates a job, and let's see. Okay, yeah, this is our job in Flink application. So I am using our own engine, but yeah, it's here. Nothing is enterprise, so everything is should work also in a Apache Flink, open source project. Okay, so now let's do a couple updates to our table. So let's create insert a order. Maybe before that, I can show something more. So this is also, since we have the Elasticsearch, it finded the index. Okay. So I create an index on that table. And since we already run the query, we should be able to see, where is it? Yeah, a result of the query from the already populated tables. And we can apply some changes to that. So let's quickly add this record. And we should be able to see it. Yeah. And also, I want to show something just to make a point here, why it works. I delete that record. It was 5, yeah, sorry. Doesn't exist here. Yeah. So the record is gone. So everything I showed before will be also reflected on a sink, which is an Elasticsearch in this case. Okay, that's for the demo. Just before, so why that works? It's basically how the Apache Flink runtime works. There is a feature called dynamic tables. It's basically table stream duality. I gave some talks last year about this. So basically, every time, for example, you have, so here we represent this as a table, but every update comes as a changelog. So since we have a primary key on our sink table, like this, all the changelogs, for example, based on the primary key, know that whether it should retract the record or update it. And since we have a primary key, it will be upsert. So if I have insert, it will be insert. If it's update, it will be upsert. If it's a delete, it will be delete. Okay. Let me switch to the. We have a very active open source community. So everyone is welcome to to contribute. Basically, if you have an issue or if you want a new features, you can reach out to the FlinkCDC project. And that concludes my presentation. FlinkCDC is a fast and reliable and robust data integration framework. It has many features. Integration with many different databases are supported. You can use different APIs, YAML, SQL, or DataStream to implement your ETL jobs. Yeah, many references. I think slides will be shared. You can check them out. All are really good articles or talks about the CDC. And I work at Verwerker, which is original creators of the Apache Flink, and we also have many different offerings for unified streaming data platform. We have a really powerful Flink engine. Yeah, you can also check it out, scan the QR code, and yeah, if you are interested, also ask me. And we also organize Flink Forward conference. It's about everything about the streaming. So this year it will be in Barcelona. So you can also, come and show all the different use cases you do with the streaming or the Flink or Kafka. Yeah. Yeah, that's it. Thanks a lot. I'm happy to answer your questions. Yeah.
Thanks, Muhammet, for this talk. And I see the first question.
Hi, thank you for your talk. I wanted to ask you about the aspect of you mentioned that you guarantee what was the, excuse me, just like I'm kind of tired. The semantics of the replication is that you make sure that you process one change only once, right?
Yes. Yeah, Flink, it's all is event processing.
Yes.
So the records which appear will be in order. Of course, there could be like on a windowing, when you do the windowing, there could be a late arriving events. But on a source, if they are in SQL, they will be in order in the through pipeline.
Yes.
Yeah.
However, how do you achieve exactly once processing or delivery if you do not lock a table and you actually read it in chunks? So this is multiple read transactions, right? And the changes to the source table can happen in the meantime. So I mean the initial load of the table on the source side.
Yeah, I think there exactly. So we have the snapshot of the table. So the ordering is not important for us at that moment. It's just providing all the data at once. And how it is done is using the state, Flink state. So fault tolerance is based on this, I forgot, Chandy something algorithm. So if there is a failure, so the operators will restart from the recovering the state. So if you are in the middle, if you are reading some parts of the chunk and the failure happens, that means that chunk was not registered in the state as finished. So and in the Apache Flink, the failure happens for everyone. So if there is a failure in one operator, the job will restart. So everyone will start their state from the. Everyone will do the state recovery, and this. States will be in sync because there will be a watermark going, okay, do your state now, and do the checkpointing for every operator, and including the sync.
Okay, thank you.
Yep.
I see one more question.
Thanks for the presentation. This is quite nice to see what all capabilities FlinkCDC has. One question regarding the differences between YAML and the streams record you mentioned. The data dictionary event is only available in YAML but not in the stream side of it. Why is it so?
I didn't understand, I think.
So let's say there is a create table event which is changing the dictionary.
Yeah.
That one is, I see, only available in YAML events.
No, the demo I showed with
not demo. Your slides were showing like that only the dictionary change events, which is like a DDL on a table, is only available in YAML. Is it not available on the stream side?
I think for the YAML, there will be the full, there will be part with the source. So that is also available in a SQL. But the sync part is only available in the YAML. Was that? No? Yeah.
So the question is from the source side. Let's assume there is a Postgres database.
Yeah.
I have products table, and I did a DDL. I changed the product ID from integer to streams.
Yeah, okay. You are a schema evolution and the data
Right.
transfer. Yeah, that will be done in YAML only.
Only YAML?
YAML, yeah.
Why so? Because everybody needs the dictionary evolution as well.
Yeah, I think, with the SQL, it's a total different algorithm with the YAML. So it's something called pipelines in the FlinkCDC. And the SQL is only the source, FlinkCDC sources. And with the YAML, it's only the new algorithm like data pipelines. You can also do the detect that in SQL. I don't think you can do it, but in data stream you can still detect it. So you can read in your binary log JDBC connection, there is a change in a schema and do something in your job. But with the YAML API, everything is done for you with the FlinkCDC.
Okay, thank you.
All right, thanks a lot for your talk.
Thank you.
We're ready for the lunch break, and I see you all back hopefully at 2 p.m. Thank you.
Thanks.